Very much for introduction, and I'd like to thank the organizer who is not here, but to give me opportunity to give a talk in such a wonderful lecture hall. And the plan of the talk is as follows. In the first lecture, in this lecture, I will try to tell you some very basic result on the p-adic representation of the p-adic local field. And for second lecture, I intended to give some survey of some comparison theorem on p-adic theory and a brief proof, but I'm not sure. But because the proof is very complicated, so maybe it will take a very long time to explain only brief ideas of the proof. So maybe I'll change it. I will change the ingredient in the second talk tomorrow. But anyway, today I'll talk about the p-adic representations. And let K be a finite extension of QP, and where P is a prime number, we fix over the lecture we fix the prime number P, and we denote by OK with ring of integers, and let small k denotes a residue field of K, which is a finite field, and also we fix an algebraic closure K bar of K, and we denote by G sub K the absolute Galois group, the Galois group of K bar over K. Alright. This is notation. And let E be another p-adic field, which will be a coefficient field of representations. And similarly, we denote the length of integers, and small k sub E is its residue field. And we denote rep sub E of GK denotes the category of E representations of GK. That means its object is a pair of V and LOR, where V is a finite dimensional vector space of E, and LOR is a continuous homomorphism from GK to the group of E linear automorphism of V. Here, where GK is equipped with the usual profinite topology, and this GL is equipped with an p-adic topology. And similarly, we denote by rep OE of GK is a category of pairs where T is infinite, regenerated, and free, modular over OE, and LO is a continuous homomorphism. From GK to the OE linear action of T. Then we have a diagram of categories and functor. And yes, in the category of E representation forms an abelian category. Abelian. And this is an additive category. And we have diagram of category and functors in rep E, G, K. From rep E, G, K to rep E, Q, P, G, K is the forgetting of E structures. And also there is a functor from rep OE, GK, and rep, I'm sorry? GK, this is a functor obtained by tensor with E over OE. And this is a functor obtained with tensor with QP over ZP. And this diagram is commutative after canonical functorial isomorphisms. This is the category of all E-linear finite dimensional representation of ZK, but there is several very important class of representations called drum representation and stable representation, semi-stable. And crystalline representations. Drum. Oh, no, sorry, I'm sorry. Thank you very much. And semi-stable. And crystalline. Yes. And we first recall this definition of these notion of subclasses. For the drum representation, we need to introduce some ring called B drum. Which can be constructed as follows. Let R be a projective limit on the diagram homomorphisms and rings, where the which is the infinite sequence of homomorphisms of ring and under object at each degrees. All this one is OK per modulo P, and the connecting map is a P power map. This is a perfect ring of characteristic P, and and that denote WR with, the ring of bit vectors with coefficient in R. Where W is some functor taking bit vectors whose input is a commutative ring, and its output is also a commutative rings, so it is self-functors. And for any commutative ring, the WA is just as a set, it is a countable many direct product of the RA as set, and where on which the addition and multiplication is defined in some ways. Yes, we are mostly concerned with the case where the A is a ring of characteristic P, and for example, the WFP is just as canonically isomorphic to the ring of p-adic integers. And also the WK, where K is a residue field of K, large K, which is some ring of integers.
What is EP?
I'm sorry? Yeah.
What is EP?
Is it FP? I'm sorry. Our finite extension, unramified. Of K, finite of QP, which is in fact the maximal unramified extension of K over QP. And then we can construct a canonical homomorphism ring from the ring of bit vectors with coefficient in this ring R to OCP, which is a p-adic completion of OK var. And if we denote by C to sub large K with a map induced from this homomorphism, whose domain is WR tensored with WK over K to CP. CP is a field of fraction OCP, and we denote by B drum plus the p-adic and the completion of this algebra WR tensored K with respect to the corner C to K. And it is and it is known that this is a discrete variation ring. With a residue field equal to CP, and the canonical projection to CP is given by this homomorphism C to K. And we denote by D drum the field of fraction, this discrete variation ring. And it's by construction, it is easy to see that the group GK, the absolute Galois group, acts on this ring, and it can be also checked that the invariant part under the axiom GK is equal to K. For an E linear representation of the group GK, we put this ROM. The ROM is in just a tensor product of V and this ROM over QV. And take invariant by GK. This is a free, it is an K times QP E module. Of rank is smaller than or equal to the dimension of V. And we define we say that V is ROM if and only if d ROM V, I'm sorry, d ROM V is the free of rank is equal to the dimension of V. And here, in similar ways, we can define the notion of crystalline representation by introducing the ring B Cris. Here is let denote by A Cris, which is a ring defined by some crystalline cohomology. The limit of H0 of Cris spec over K over P over spec WK over P to the N. This is the definition, but we do not explain what is this one, what is this guy, but it is some ring here. And also this ring has an alternative, very explicit construction and description, which I'll explain now. And A Cris is in fact is canonical isomorphic to the p-adic completion of the PD envelope of the ring which I used, WR, which I have used to define beta ROM, and the corner of theta, which is the idea, and over something like over ZP and P.
In the first definition.
Oh, this one. This is K bar. Yes. Yes. This is the shortest definition, and this definition is useful to prove the comparison theorem, for example, between Italian crystalline cohomology. But in some algebraic study of the crystalline representation, the latter explicit definition is more convenient. And yes, a PD envelope is some, which is a PD envelope is something like a ring, is a triple of a ring, and it's ideal, and it's some system of maps from the ideal to the ring, called some PD structure, which can be defined for the pair of ring, for a given pair of ring and ideals, and also which is over some triple, which is some standard PD structures. Standard. Anyway, it is a ring, which is similar to this, which is obtained by slightly enlarging the original ring, this one, by adjoining some powers of the element in here, divided by some power of some factorials. But anyway, we have some. Yeah.
p-adic.
This is PD. PD means this one.
p-adic completion.
p-adic completion. Yes. Yes.
What is PD?
PD means a divided power. Yes, divided power is a structure. Yeah, divided power of some pairs of a ring and its commutative rings and ideas in the systems of maps indexed by non-negative integers from I to A. And such is satisfying some several properties, but the important point is that the delta nx is like an x to the n divided by the factorial of n. And now let's choose a system of p powered roots of unities in K-bar. Where zeta of p to the n is a primitive, p to the nth power root of unity, satisfying the p sub p to the n to n plus 1 to p is equal to p sub p to the n. And then this system defines an element epsilon. It is just p to the 0. This is equal to 1 p squared, which is an element of R, and then we can take a Thai-Himilo lift, which is an element in the ring of bit vectors, because that it is isomorphic as a set, as a direct product of infinite copies of Earth. Then this is an element corresponding to the element whose first factor is equal to epsilon and the other factor is all 0. then it is easy to see that epsilon, Taihimla character epsilon minus 1 belongs to the corner of theta. Then we can define the element t is a log of epsilon, which is by definition is some sum of minus 1 to the n of minus 1, where n runs over the positive integers. E minus 1 to the n divided by n. Yeah. But which is an element belonging to an A cris? So far we have constructed a ring A cris and its special element T, and we then define the cris to be the ring adjoining to A cris and P inverse and T inverse. Then it follows from the construction that the group GK acts on B cris, and similar to we define the D cris V for the V E Riemann representations. B cris tensors with V, and taking GK invariant part, and this is a finite dimensional finite rank module over K0. K0 means a fraction, field fraction of the ring of bit vectors of the residue field of E and residue field of K tensors with E. And we say that V is crystalline. If and only if D cris V is a free rank, free modular over K0 tensors with E, whose rank is equal to the dimension of V. And similarly, there exists, we can construct a ring BST but to construct this ring, we need to fix a uniformizer of K. But anyway, if we fix once for all the uniformizer of K, then we can construct the ring BST, and which is between B cris and B drum. There exists a canonical injection from B cris to B drum, and then this ST is lies then between these two rings, and some similar way we can define D stable V and V is semi-stable. The notion of V is semi-stable. Free of rank. over K0 tensor with E. And the round and crystalline and semi-stable representation is very important objective studies because
What is DST? DST.
Oh, DST, yes. DST can be defined in a similar way, but taking tensor product.
Oh, what I mean, DST.
I'm sorry?
DST. You said that there is DST.
Where? Where?
P.
DST. He hasn't defined it. He just said there is a definition. DST.
Where? Oh, this one?
Yeah.
You asked a definition. Oh, it is as an algebra. This is a polynomial ring over decrease of one variable. Yes. Its variable is denoted by usually u named u, and this element is an element in B DRAM, and a special element, and we can construct this element by fixing a uniformizer.
So GK state. GK invariant.
Yes. The full ring is a GK invariant. Yes.
Actually, you choose DST like this one. So you can choose another choice.
Yes, there is several choices. There are several choices. Yes. But the notion of stable representation is independent of the choice of a uniformizer. Yes, these notions, semi-stable DRAM and crystalline, is very important because if we consider some motive over variety over p-adic field and take its étale cohomology, then we can produce a lot of examples of p-adic representation. But all such representations are known to be DRAM. I will talk on this topic in the next lecture. In the remaining time of the first lecture, I will give an explanation of some classification of representations. And classification means means the following way. We have considered some representation over something of GK satisfying some property, crystalline or DRAM or stables. But its definition is very complicated, so we can make the structure of this category is by establishing an equivalence. Want more simpler categories or simpler. And for the object or morphisms are defined by using more or less like a linear or semi-linear algebra. Yeah. There exists a lot of theory between such kind of equivalent or concerning such kind of equivalence, and we would like to explain some three of these theories. All of them are very is something classical nature, but The first one is a representation of a E-linear representation or OE-linear representation can be classified. There exists an equivalent category in the theory of phi gamma module. And the second one is concerning the E-linear representation and which are crystalline. Yes. These representations are classified in the theories of weakly admissible, filtered phi mergers. And the third one is some representation of OE representation, but under the assumption we assume that the T tensor QP, which is the E-linear representation, it is crystalline. With small Hodge state weights, which I will explain later, which are classified by using a theory of Fontaine and Lafayette, and there exists a projection between these representations, isomorphism present of these representations to the set of so-called Fontaine-Lafayette modules. Here. In my third talk, I will explain another classification result, which is due to Bach and Colmetz in Belgium by to classify the order that is of crystalline representation in terms of Bach modules. And the phi gamma module is as follows. With that K in sub-infinity denotes a field obtained by joining all the p power roots of unity, and let HK denotes an absolute Gala group of K infinity, and there exists an exact sequence. HK is the normal subgroup. And the quotient we denote by gamma k. And a cyclotomic elixir gives an injective homomorphism from gamma k to the GP cross whose image is a finite index. Well, then we should introduce another kind of rings. We let E tilde denotes the field of fraction of R, where R is the ring which I have introduced in the definition on B drum, which is a projective limit of p power map with respect to p power map of OK bar over p. And that A tilde denotes the ring of bit vectors with coefficients in E tilde. And let B tilde its field of fraction. It is a field. It is a perfect field, and it is some discrete variation ring, and it is a ring of fraction of A tilde. And there exists an element. In A tilde there exists an element pi, which is defined by the Thai-Himila character of epsilon, which I have introduced in the definition of small t. And that's one. And we let AQP denotes the p-adic completion of formal power series with respect to this pi. And this is a ring of formal power series and taken p-adic completion. But this can be embedded in A tilde by sending pi to pi. And then this is also a discrete variation ring with residual fields not perfect, but we let BQP denotes its fraction field. Then this is a discrete variation ring, and we denote B is a maximal and ramified extension of BQP inside B tilde. Then B is an infinite Galar extension of BQP, whose Galar group is canonically isomorphic to the absolute Galar group of the residue field of this AQP, which is a local field of positive characteristic P. Then we let AK denote the invariant part in A under the action of HK, and also and for here. And for an OE representation of GK.
What is HK?
HK is an absolute Galar group of K infinity. It's the corner of cyclotonic character. Here. Yes. When K is QP, this definition as this notion is compatible. Yes. For an OE linear representation of GK, let dt denotes A tensored over CP, T, and taking invariant part by HK. Then this is an AK tensored OE module. And the fundamental theorem proved by Fontaine in the theory of Phi module is as follows. This is the main theorem of Phi module. the function D gives an equivalence of category, and for the category of all linear continuous representation of GK to the étale, so-called étale phi gamma modulus over AK tensor with OE. Yeah. The object of the right hand side is in this object is D, which is the finally generated free modulus over this ring, and equipped with some endomorphism B, denoted by phi, which is semi-linear endomorphism. And here semi-linear means as follows. There is a p power map on E children induces an action of sigma, which is called Frobenius, and which A children, which we denote by A children, and which induces and this is an isomorphism. This induces an endomorphism of some ring AK. Yes, the semi-linear is an semi-linear with respect to this endomorphism. And also, the gamma act varies continuously with respect to some topology which I have not explained here, and acts on this ring, which is also semi-linear action, because this group also acts on this group, gamma K, sorry, and satisfying some conditions, then such that the action of phi and action with gamma commutes is the first condition. And the second condition is the étaleness of the action of phi, which is the action of phi induces an isomorphism from D tensored with AK sigma AK to D. Yeah. This is the theorem. So yeah, and this also induces, yes, the similar equivalence is also established for the E-linear representations. I don't remember. Weakly admissible. I would like to explain what is weakly admissible. Phi modulus. I feel that. Sorry, feel that. And the ring B drum has a decreasing filtration whose field I part is defined to be the T to the I times B drum process. this filtration induces an decreasing filtration on D around V. Also, there is an action which denoted by sigma, which also acts on W of R, which induces an action which we usually denoted by phi on B crease, the ring gate B crease. This action induces an action of phi denoted by phi on D crease V. So this structure, this filtration and action of phi defines an extra structure of decrease of V. So decrease if V is crystalline, decrease V is in filtered phi modules, and which is a finite dimensional vector space D equipped with semi-linear endomorphism and also equipped with a decreasing finite filtration where dk is the tensor product of d and k over k0. We note that the decrease V tensor k is canonical isomorphic to d from V in this case. And the main theorem around here is the following statement, which is conjectured by Fontaine and first proved by the Cormels and Fontaine and Air. And now several alternative proofs are known, and this decrease equipped with the extra structure above induces an equivalence category between the leaf E crease G K and the category weakly admissible filtered phi modules over K0. Where I'm sorry, the over K. Yeah, over K0 is in. I'm sorry if it's insane. Yes, K0 tensor with E. Where the filtered phi module is called weakly admissible. If it is weakly admissible as filtered phi module over K0, and which is by definition is as follows: for any d prime which is a sub K0 vector space. And stable ended action of phi. Then we have an inequality between the p-adic variation of the determinant and eigenvalues of phi on the determinant of D. The phi is a semi-linear action, so the eigenvalue is not uniquely determined, but its p-adic variation is uniquely determined. It's larger than or equal to the sum of I times dimension of GU I is a graded part with respect to the filtration field. Filtration on D tensors with K induced by the filtration on D times O times re tensors with K. This is a definition when weakly admissible. So the category of this is just a semi-linear object and very easy to describe. So we use this equivalence category to explain the problem and the result in the self lecture. Okay, then I should stop here. Thank you very much for the attention.
What is determinant? T